Good morning to everybody, and afternoon and evening, as it were, around the world. Thanks for joining in. We're going to be talking about the zipSTOP IR today. It's a new device we released 4 months ago. We'll also be talking about new pivot mount operation for it and some other exciting head rush products. Today, you'll see this is going to be the first of a series of slides, webinars for us to go through the zipSTOP in the future. We're going to talk about a bunch of advanced stuff in the next 6 months. Today's guidelines are going to be pretty basic. We're going to talk about a quick review of the zipSTOP operational guidelines. Those are what you're used to from the manual. We're going to introduce the zipSTOP IR, talk about the pivot mount. Then we're going to do a quick overview of upcoming webinar content and look at zipSTOP related products and topics coming up. And then introduce some new exciting HRT products to help with zipSTOP installation and operations. I may go on and off the map today as I describe a little bit of the behind the scenes to help you guys understand how and why these things come to exist and how we do the design process. But for the most part, we'll stick to it and try and stay on schedule. My name is Peter Kachetis. I'm the Senior Development Engineer here at HeadRush. We have an engineering team of 9 now, and we're working on quite a few new products, and this will just be, like I said, the first of many of this webinar series. So today the schedule is to we're going to talk 45 minutes in pre-programmed stuff here where we watch a few videos and I go through the basics, a few advanced infrastructure things that get us started on a more in-depth conversation. After that, we'll do 20 to 45 minutes, depending upon how many questions we get and how related the questions are to the content. In general, the questions we're going to want to be talking about today are anything with the zipSTOP IR, pivot mounts, challenging installation questions we'll touch on a little bit, but it's going to be the subject of several more webinars, so you may get from us that could be an upcoming webinar. And anything else zipline related. Certainly we welcome other questions at the end if we have time on the quick jump or the True Blue product line or anything else that you may have heard or seen us coming out with in the next year or so. So with that, let's go ahead and get started. We'll talk about the zipline first, and we'll go ahead and show this video if you haven't seen it already.
The zipSTOP is the best brake available for your zipline. The zipSTOP uses a self-regulating magnetic braking system for operators. The zipSTOP zipline brake is a controlled braking force designed specifically for use in the zipline industry as a primary or emergency arrest device at the end of zipline run. This video provides an overview of zipSTOP operation and installation concepts. Please refer to the zipSTOP installation, operation, and maintenance manual for complete information. The zipSTOP brake unit is located at the zipline terminal end, normally adjacent to the landing area. It is mounted using the brake unit mounting bracket. It is connected via a redirection pulley and reduction line system to the zipSTOP brake trolley. The brake trolley is located on the zipline and, when idle, will be positioned at the start of the rider arrest zone. The approaching rider trolley contacts the brake trolley, moving it down the zipline. As the brake trolley moves into the arrest zone, it extends the braking line out of the brake unit via the reduction line. As the braking line extends out of the brake unit, the eddy current brake in the brake unit is activated, controlling the rate of deceleration and slowing the rider in a smooth manner. In a standard 1-to-1 or 2-to-1 configuration, once the load is removed from the brake trolley, the spring return mechanism in the brake unit retracts the braking line, automatically returning the brake trolley to the start of the arrest zone on the zip line. The zipSTOP brake assembly is designed to be used as part of a complete zipline braking system and can be used for a wide range of zipline installations. zipSTOP is suitable for use in both existing and new zipline installations. Setup information provided in this video and in the manual relates only to the zipSTOP brake assembly. The design, installation, and setup of other components comprising the complete braking system are the responsibility of the installer and/or operator. A number of variables will influence the final braking distance and level of rider comfort. Rider arrival speed is unique to each zipline installation and is a factor of the line slope, zipline length, rider weight, rider descent position, wind, and friction. It is necessary to know the acceptable minimum and maximum rider velocities prior to configuring the zipSTOP. Suitable rider weight ranges will need to be determined by individual zipline operators. The zipSTOP brake unit will accommodate riders between 33 and 330 pounds, or 15 and 150 kilograms. It is necessary to know the acceptable rider weight range before configuring the zipSTOP. Reduction line ratio is the most influential factor in the braking characteristics of the zipSTOP. The reduction ratio is the difference between the brake trolley travel and the braking line extension. The reduction ratio is achieved by passing the reduction line around a series of pulleys. This alters the ratio of brake trolley travel to braking line extension, allowing the installer to tailor the braking distances and deceleration rates and accommodating a wide range of arrival speeds and rider weights. Reduction ratios include 1-to-1, 2-to-1, 3-to-1, and higher. The 1-to-1 reduction ratio directly connects the brake unit to the brake trolley via a single pulley. For every unit of brake trolley travel, the braking line extends an equal distance. Characteristics of the 1-to-1 ratio are suitable for low speeds, strongest braking force, short braking distance, higher rate of rider deceleration, maximum approach speed of 22 miles per hour or 36 kilometers per hour. The 2-to-1 reduction ratio connects the brake unit to the brake trolley via a series of pulleys. With the 2-to-1 ratio, the brake trolley travels twice the distance that the braking line extends. Characteristics of the 2-to-1 ratio are suitable for medium to high speeds, optimal combination of stopping distance, braking force, and reliability in reset. Longer braking distances than a 1-to-1 setup, overhead support line recommended, maximum approach speed of 36 miles per hour or 60 kilometers per hour. The zipSTOP brake assembly can be used with other zipline configurations and higher velocities. Contact your zipSTOP distributor for more information. 3 configurations at the end of the zipline are possible: positive line slope, flat line slope, and negative line slope. The slope of the line will influence the braking distance, as well as allow the rider to roll slowly up or down the line once decelerated. Positive line slope is the ideal configuration when designing a zipline for use with the zipSTOP. Positive line slope configuration equalizes the braking distance between heavy and light riders, therefore minimizing the length needed for the arrival platform. On positive line slope installation, the zipSTOP will decelerate the rider within the arrest zone, but allow the rider to continue to roll slowly forward on completion of braking. Both heavy and lightweight riders will arrive at the same location. On a flat line, participants will decelerate within the arrest zone at the completion of braking, but typically don't roll forward or backward. On negative slope installations, riders will decelerate within the arrest zone and may roll backwards at the completion of braking. System friction and environmental conditions such as wind are other variables that could affect rider speed. A configuration worksheet is provided in the operator manual. Complete this worksheet using the information contained in the braking distance chart, also provided in the manual. Always carry out unmanned testing to determine actual braking distance. The information provided in the manual is intended for guidance only. The zipSTOP brake unit is installed at the end of the zipline, usually on or adjacent to the terminal end. A secondary anchor point is normally required upstream of the landing area to provide support for the reduction line pulleys. The ideal configuration aligns the zipSTOP brake, redirection pulleys, and brake trolley on a single plane. Please see the installation, operation, and maintenance manual for alternate configuration possibilities. The basic steps to install the brake assembly are: identify your primary and secondary anchor points per the instructions in the operator manual. The primary anchor point provides support for the zipSTOP brake unit. The secondary anchor point is redirection pulleys, traveler pulley, and hardware used in the reduction line system. Fit the zipSTOP brake unit into the mounting bracket. The zipSTOP brake unit may be mounted horizontally or vertically. The mounting bracket is designed for use with a flat or curved surface. Fit the brake trolley. The brake trolley is installed on the zip line and is used to transfer the energy of the rider to the zipSTOP braking unit. Fit the redirection pulleys and reduction line. The installation of the redirection pulleys and reduction line will vary based on your configuration. Ensure that the reduction lines are routed cleanly and in line through the pulley system to prevent contact with the rider or any surface other than the pulley sheet. Installation tips and safety precautions. Refer to the installation, operation, and maintenance manual for complete information. Always correctly install, maintain, and operate the zipSTOP brake assembly. Proper design and testing of the complete brake system is always required. Always operate the zipSTOP brake assembly with an emergency arrest device system active. Always use the correct zipSTOP brake trolley. Avoid contact between the rider and rider trolley and/or brake trolley. Ensure all cables, attachment lines, and pulleys are correctly attached and maintained. Ensure that the brake trolley always resets to the start of the arrest zone and that the zipSTOP braking line is fully retracted into the brake unit at brake initiation. If problems occur during operation, check the troubleshooting guide provided in the operator manual. Recertification and maintenance. The zipSTOP brake unit, braking line, brake trolley, reduction lines, and associated pulleys must be inspected on a daily basis for condition and correct operation. Please see the installation, operation, and maintenance manual for complete inspection procedures. Annual recertification is required for the brake unit. The unit must be returned to an authorized service center prior to the next recertification required date on the certification label. For more information on recertification, visit thezipshop.com and select recertification.
Okay, so you may or may not have seen that video before. We'll send you a link to it, certainly, as the audio and the visual is a little bit jumpy there, but we'll send you a link to it so you have access to those basics. But we're going to move fairly quickly beyond the basics today, but we might as well go over the zipSTOP. You see a picture on your screen. That's the new zipSTOP combined manual. It now covers both devices. There's quite a bit of work that went into the manual as far as making sure that we could distinguish between both devices at the same time while giving you all the information you needed to install either one. It is available for download on the website if you want to sign up, and there's also a bunch of other things. What you'll notice when you get in there, and most of you are familiar with at this point, is the braking distance charts. This is an example directly from the manual, 13.7, 2-to-1 imperial braking distance. This is for a standard zipSTOP install with an external 2-to-1 reduction. The IR is similar, but what you'll see in the manual is a little different. I'm going to switch over to the manual and show you guys a few of the differences there as far as the new IR. So give it a second and it'll should pop up here.
Yep, there it is.
There's everybody's worst nightmare. The charts requires you to do all of the math. We did simplify it a slight bit, but it didn't get a whole lot easier. The manual is kind of a beast now. It's quite a bit longer now that it incorporates both devices, but we'll skip to the end for the purposes of the braking distance charts right now and show you basically what you're looking at. They're also two different colors so that there's no confusion. We'll make this a little bit larger, make it a little bit easier to read. So we get down to the braking distance chart. So here's now the IR chart. You can see it's in color rather than the orange. Another IR chart. So this is metric and imperial. Because we're a worldwide company, of course, we deal quite a bit in metric, and then we do the translations backwards for the imperial standard so that everybody's speaking the same language. And then the older charts, which you're already familiar with, 1-to-1, and the 2-to-1 charts for the external reduction. We have not included 3-to-1 charts. Again, that's still going to be something that you're going to want to email us on and get the custom information from us. But we'll refer back to this a little bit later as we need to. That's the new manual, and you should have all the information that you're looking for in there going forward as far as the basics go. Let's move on to, of course, there's the calculation chart. If you ever struggle with this, please feel free to contact us at HeadRush. We'll help you through the chart, help you understand it. Key points here get missed a lot are, making sure that you measure your speeds. It's tough to estimate speeds on a zip line just for a multitude of variables. You've got, believe it or not, a large portion of the variables is tied up in friction and wind, not so much cable inclination and tension, which is the misnomer out there that just doing a catenary curve calculation will get you approach speeds in the ballpark. Truth is, the best ballparks and even our ballpark software that we're working on relies heavily upon frictional estimates. If you were not to have any friction, you'd see arrival speeds at 30 to 40% higher than what you actually are seeing out in the world. So friction's playing a massive part, and of course that also is a limiting factor when you're talking about designing zip lines for higher speeds. So let's talk a little bit about where the data comes from before I get too far off on my tangents. And I'm going to show you a little bit of behind the scenes here. This is also something we're going to release in the future, although I don't have a current day for when we're going to release this. Give it a second and it should come up. So internally, we've spent quite a bit of time modeling the brake dynamics of our internal eddy current devices. So across the board, obviously our job is in engineering these devices is to know exactly what they'll do at any given time. So the way that's manifested is in one of these monstrous beats. This is an example. You can see there's probably 20 or 30 charts that tell us exactly, based upon the physics and the measured dynamics from thousands of tests, where and how the device is going to react based on speeds. This is kind of a behind the scenes. It doesn't give you all the math behind it, but you can see this is nothing more than an advanced Excel table that tells us braking performance. But the really cool thing is now that we've got years and thousands of tests underneath our belt, we've nailed this theoretical down quite tightly, and we can change these over here on the fly and give you a reasonable estimate of where your braking distance is going to fall. So an example is standard zipSTOP. We'll do an IR. So we have an IR modeled here. It has a different internal gear ratio, which we'll cover here shortly, and it uses only a 1-to-1. 165-pound rider approaching at 40 miles an hour, 64 kph, will take approximately 48.2 feet to braking. And I apologize, this doesn't have the conversion in there for meters, but you can see from the chart down here, you're right at 13.5 meters of braking distance. Now that's total braking distance before you, and you haven't arrived at zero, so zero is approximately here at 48.2 feet. This also models the force of the retraction spring, which you guys may or may not be familiar with at this point extensively. The retraction spring is a significant force as you pull further and further out on the webbing. So this is where the data comes from. I've got some sliders here to give us maximum weight. There you see the IRs. If you read the chart straight from our charts, 62 feet is the rated maximum for 37 miles an hour, which is here is 40 and 330 pounds. Of course, we have a little bit of padding in those charts, and they're not super high resolution because they're relatively small, but this is where it comes from. Again, we're going to release this at some point in the future and allow you guys a user interface that looks very similar to what you're looking at here. A little bit cleaner, a little bit prettier. This is a little engineering right now, but I'm sure the marketing department will make this pretty for you guys later on a web interface so that you can change these key items. You'll be able to just pick the checkbox for the IR and standard. Use your slider to approximate your rider weight so you can deal with your rider weight range from 35 all the way up to 330, and then rider speeds. And you can see we built in a little bit of overhead here so we could take the device over speed. It's important to note for today's conversation what does happen when you go over speed. And really why the IR, I'll come back to this when we talk about how the IR came into existence, but you can see that behind the scenes here I haven't flagged anything as far as issues. I cannot open up this tab now because it would tell you exactly where our safety limits are, and we're not going to release those publicly, but this is a minor overload situation, and the brake's still performing exactly as it should. The truth is, even in extreme overloads, the brake is still going to continue to work. You're just going to begin wearing the unit out abruptly, and at some point you'll wear the unit out to the point where it's going to have to come out of service if you overload it. But the good news is, just like the TrueBlue and the rest of our devices, it's designed so if any failures occur, they fail towards safe. It's impossible to fail on the other way where you would have no braking. So move back into the PowerPoint and continue on with how the zipSTOP IR came into existence and why. So what changed? Well, we changed a few basic things, and some of it's to make your life a little bit better. It's going to come up here in a second. Braking distance. So the standard zipSTOP, even in a 2-to-1, does not use all of the webbing, but it brakes over. It's really coming up slowly. That automatically does. Coming. What you're not seeing right now is the standard zipSTOP, let's say at the maximum rider weight of 330 pounds on a 2-to-1, would take up 37 feet of the webbing, which is 74-foot braking distance. The IR does this same duty in 62 feet. So get a shorter braking distance. There's also a difference in the retraction spring, which we're going to go over next. But the shorter distance is going to save you a lot of money on your platform builds. Let's see if we can get this to
Stop sharing and share again, perhaps.
Yeah.
Sorry, buddy. We're just trying to make our screen show up.
See if we can get this to share again. There we go. So, as I was saying, the retraction spring changed. Several reasons. Power spring technology hasn't changed a whole lot in 100 years. It's still the best and the best way to deal with these types of mechanical retractions. No real new technology out there, even on the horizon, ironically, because it's so reliable. But the new retraction spring has to obviously wind up 65 feet of webbing versus the original 42 feet, or 20 meters versus the original 11.5 meters of webbing. The good news is, because power springs lifespan is dependent upon quite a bit of how they're wound and the material they're wound from. Because the material gets thinner and we don't have to deal with trying to reset an external 2-to-1, you gain a longer life retraction spring. So not a lot of what we talk about up front in marketing and sales is about the lifespan of the retraction spring. The reality is it's a fatigue item. All metal items are, especially springs. So as they cycle over time, they will wear out. That's kind of their core design. The existing zipSTOP spring can wear out abruptly. For example, if you're pulling the webbing all the way out to 42 feet, you're burying the spring and causing a whole lot of pressure on the center of the spring. And eventually that will create a failure. And as short as 5,000 to 6,000 cycles, depending upon how it's used and where it's used and the environment it's used in. The good news is the IR uses a spring that has almost an order of magnitude in durability. So whereas the standard zipSTOP spring may see a 5,000 cycle, and this is an arbitrary number, but the IR will see 50,000 type of cycles, and it can be pulled all the way to dead solid without fatiguing the center quite as bad. Pulling the webbing all the way out will still fatigue the spring. It's inevitable with a power spring that's the way to fatigue it, but you'll see a much better and longer life out of the retraction spring. All the springs and all the units have gone to stainless, so there's no real weather or corrosion issues to deal with, but you should know that the retraction spring is a little bit lighter in peak force and better in average force than the IR. What that really means is arrival is going to be more consistent. So if you have a positive slope line like they were discussing in the video, your riders are going to want to continue traveling down the line, fighting a whole lot less resistance. If you've played with the standard zipSTOP, you know that at full extension, that thing is like fighting a bear. It can be up to 45 pounds of force fighting you as far as keeping the trolley extended out, which can really make your operator's life hard if you're using a methodology that extends the webbing close to near its maximum. Generally, you're not near there, so the force is not that great, but nonetheless, it's part of getting people on and off your zip lines. Other changes in the IR, the braking mechanism. So I alluded to this a little bit earlier when I talked about the behind-the-scenes math, but the transmission ratio and the internal reduction ratio is different in the IR versus the standard zipSTOP. This, of course, made us, we optimized the brake speeds for the existing speeds so that we could transfer one device into your existing setups more accurately. It's not that we may not deal with a higher speed internal reduction device in the future, but this one's optimized for maximum braking performance at the maximum current webbing design that we have, that we're comfortable releasing in the world, which is the 65-foot, 20-meter webbing internally. The good news is, like I was saying earlier, this really gets your arrival points down to a much smaller point, so you can avoid really exotic and amazingly expensive towers like in this picture to deal with your arrival points. Certainly, you know, those types of level of professional installations are obviously work well, but the game here is get your zip lines up without spending a fortune on construction and engineering for towers and infrastructure if you can avoid it. So standard zipSTOP, 2-to-1 internal reduction. This is straight off of that calculator I was showing you. So we have the charts, and then we switch for the same rider to the IR. You can see very, very little change. Again, we do have a slightly shorter braking distance with the IR, but it doesn't really show up until you're talking about heaviest riders at maximum speeds, which is really your performance envelope, right? If you're designing a zip line installation, you're always designing around your maximum rider and your maximum speed, including tailwind, to deal with it safely, and then trying to figure out how to dial in your lightest rider with your greatest headwind back the other direction. So I'm going to show you a little bit of the alpha testing. This was an alpha unit of the ZSIR that we were testing back in the end of 2013. This is some live testing with a 235-pound rider, so I apologize for the nature of the video because it's definitely an internal engineering video. So, just as simple. What you can see though in this video right here is, see if I can make my pen work here. This here is the a racer line. You guys are familiar with two racer lines. We have a 2-to-1 on a standard zipSTOP here, and then over here on this side we have the IR with a 1-to-1. And we've removed this redirection point, which is normally anchored for the 2-to-1 just to rig it. And there's also this big ball of webbing. Not something we endorse, but when you're testing the very first iteration and you want to make sure that everything's tuned, this is a great way to tie up your reduction line before you're absolutely positive and you cut it and terminate it, which can be an expensive and involved process. You see 234 pounds arrived basically in the 50-foot distance here. You got him right to the platform. So in most cases, the ZSIR will directly replace an existing 2-to-1. So the good news is if you have a positive slope installation, this is absolutely the case. So you can literally pull down your 2-to-1 external rigging with a standard zipSTOP. Pay us for the upgrade fee to upgrade your unit when you're in the middle of the downtime or at your recertification interval, and then replace it, plug it right into the existing bracket, and pull down your hardware and change your redirection line. This of course saves you a lot of wear and tear and stress on your external rigging and your pulleys, and a lot of tangling issues as well. There are some challenges. 62 feet of webbing extracted from the unit can obviously mean that you could end up with some sagging, and we'll talk about that a little bit later, in your redirection line. If you do have a negative slope arrival or a flat arrival, you may have to adjust. Again, the brake's got a little different dynamic in terms of the retraction spring and the way it applies the brake forces. So in the standard unit, if I were doing brake force over time, brake force would come in like this. In the IR, brake force is more like this. So it's a little bit broader. The implications of between this and this can be up to, like I said, at your maximum rider, this can be as much as 10 feet. At your maximum rider weights and velocities. So it can take some tuning to get that dialed in, but in general, those are the basics for how you're going to take the IR and put it where the standard zipSTOP is sitting. So it's very straightforward. We're going to talk about this template a little bit later, but this is going to be our tool for the rest of this webinar, and I've got several of these where we'll talk about how we rig these. Basically, for example, this is the way this will go. We've got our redirection point and our brake trolley here, and the standard IR configuration is going to be like so. That's going to allow just its one-to-one, and then of course what is essential to the IR is a traveler mechanism tied here. If you don't have this traveler, you're going to find that this will want to do this quite badly, even with a lightweight redirection line. And this angle here, which we do not talk about in the manual and we'll be adding in the future, this angle here adds quite a bit of friction on reset. So if the angle ever does do this number versus straight in here, you're going to have trouble retracting this last several feet. The weight of the webbing is going to want to keep this tether extended out here. This, of course, is unsafe because you've got this hanging down here where it can collide with the zip line and a couple of other key issues. So this is a standard 2-to-1 ratio straight from our manual. You've seen this drawing before, hopefully, and you may or may not be familiar with rigging this. This is 90% of the installations in the world use this methodology. Reason being, it deals with the speeds the best. So what you'll find, and most of the pros here that are in this webinar would totally agree with me, that even when you're talking about low speeds, under 17 miles per hour, it tends to be, if you've got the room to deal with a 2-to-1, it's even better to use the 2-to-1 here. Very, very low speeds, you are going to be on the 1-to-1, but despite what the charts say, the braking performance is a little bit smoother and a little bit easier to apply to your riders over a longer distance if you can go to the 2-to-1. This, of course, is a huge advantage for the IR because it's there to duplicate and improve upon the 2-to-1 external rig. This is a prime example of a really good-looking 1-to-1, but by no means is it the only way to rig this. This is the most straightforward way. You can see this joint right here is a perfect T. That means at no point while the forces are applied here along the line does this want to go up or down, which will create a whip effect. If you end up with your line tied up around in here, this is usually the first place to look. This is the second place to look if this joint is really loose, and the third place to look is tension here if you're getting a lot of movement out of your redirection point. The best performance, what we do not model ever, is having this dynamic. Of course it is. Any kind of wire rope is going to create a dynamic load point here. If you've read our white paper, this is less than 2 kN. So it's not a huge load. Doesn't mandate you putting in a massive cable, but again, if this can be fixed, if this is rigid, it's a big plus. So solid davits, gantries, these types of things are better redirection points. Even if they're offset, a tree is actually a better redirection point than an overhead cable. Not that we would ever discourage putting in an overhead cable. This is great for service and it this way. You just have to know that you're going to end up dealing with line dynamics and harmonics. So what if all the reduction was handled inside the brake unit? Why use any reduction lines at all? So, of course, what if the reduction line was handled inside the brake unit? We solved that with the IR. But now we're talking about, what if we could just get rid of all of the redirection points? And what you're looking at is a rendering of the ZS pivot mount. This is our new product that we're here to talk about today. It gives you a completely new methodology for installing it. It has some challenges, but it has some amazing benefits. So top of the list for benefits is 0 reduction lines. Not having any reduction lines reduces your risk significantly. If you talk to a lot of operators, many of the people here, your number one risk exposure is not our unit and our webbing, it's the external reduction lines associated and pulleys. Specifically line jamming in those pulleys, lines wrapping around zip lines or overhead cables, interference with the lines, your operator not paying attention to when the jacket has been abraded on a redirection line, etc., etc. The list is long and sorted, but 98.9% of those failures out there that cause issues are usually redirection lines. The other 1% make up hardware failures in badly maintained hardware. But at no point is that ever the zipSTOPs. We've had 0 failures so far as in terms of the zipSTOP failing to brake. We've had some abrupt braking situations as it's been overloaded, but again, we talked about that earlier. Is you can overload the device, you just tend to fatigue things to an extreme degree. The webbing tether is direct to the brake trolley. That's going to make an obvious benefit. Same with the reduction lines. 0 reset issues. You're going to see how fast and quick and positive it resets, and shortest fast speed braking distance. So by not having a reduction system, the IR has been optimized so it doesn't have nearly as hard a hit at initial braking. The good news is that allows it to be used in this direct drive type of situation so that you're not really causing your lightweight riders to impact the line. Low risk, like we're talking about, no redirection lines to cut or abrade, minimal moving parts, and fastest reset. Cost savings, you get to save money on all of the redirection equipment. So here's a test video from one of our partners. I think he's in the webinar right now. Talk a little bit more about this, but this is an IR located vertically. You can see it's hung straight down, just like that. We've since changed this orientation a little bit, so it's now 25 degrees off axis to help facilitate when the webbing is pulled out in this direction. So we'll go ahead and watch this video. Arrival speed on this is right at 60 kph. And one thing you can see here in the video is there is one new exposure item with this methodology, is the webbing will touch your zip line, but it's not being pulled with force over your zip line. And we've made the new webbing on the IR out of the same thing that's in the TrueBlue XL, which is a high dynamic content specialized construction webbing. So it's super low friction and it's super abrasion resistant. So it's going to last a whole lot longer than your typical redirection systems, even when it's touching the line occasionally on reset. Again, if that was jumpy, we will be able to send you those links if you request these specific videos. These are internal engineering videos, so they're not going to be publicly released, but if you request them, we'll certainly pass them along. So, challenges. This is the big one, 4,000-pound anchor. We've mandated that a 4,000-pound anchor be used, but it already has a safety factor in it, and this is kind of an important point to talk about safety factors in the device as it is. We've already built in a 5-to-1, so it's important you talk to your engineering team when you set up and don't let them multiply your safety factor. We can, of course, provide them with actual white paper loading for the actual loads on the device if they want to put in their own safety factor, but you need to know that we already have a 5-to-1 safety factor built in. This generally covers almost any kind of ride and amusement type of standard or life safety standard is 5-to-1 standard safety factors. So you shouldn't need to engineer around that, but it would be tragic to find out that we saw an installation out there and we had a massive 4-foot I-beam sitting out over the top of a cable to carry an array of 3 or 4 of these zipSTOPs on a quad line or something like that, just because safety factors got multiplied. Again, webbing can contact a zip line on retraction, so you should note this could and probably will increase webbing wear. Not a ton. This isn't going to be something you're going to go through webbings like crazy, but it needs to be covered with your operators in terms of how they deal with it, how they inspect it, and it becomes an inspection point. Like I said, the webbing is different, so it's far less friction than the older style black webbing that was contained in the standard zipSTOP, so it's going to be far more durable. So here's an example of a very, very basic offset davit gantry. This would be the zipSTOP IR here, and you'd have a pole system. You could anchor this with guy wires on both sides, or this could be, you could have another set of racer lines coming through here on a T type of formation for the IRs, but then the IR would do nothing more than, excuse me for that, just lost our, let's go back here, my apologies. So IR is going to come down here and attach to the brake trolley directly there and handle braking along those lines. Again, this is just a simple example. There's a million ways to skin this cat. This could be an overhead gantry, so it's got another post here. That's really common. It's going to save you a little bit of money, but you're also going to spend some money on 2-footers here for your poles. They could be steel or wood, any number of configurations in order to help you install this way. Like you saw in the video, is some square steel tubing attached to some truss. Really just comes down to your engineering and, of course, your 4,000-pound loading. So now in 2014, you're going to have 2 options here in July. You'll be able to pick your mounting kit. You'll have this or the zipSTOP. This is your traditional mounts to a post, wall, any type of arrangement there, but it doesn't pivot. It's important that the vertical mount is always put on a pivot. If you were to mount this vertically down towards the line, you would wear the webbing quite abruptly if the unit's not allowed to rotate under load. So that's going to cover it as far as the basics for today. I do want to talk about some things that we will be covering in the future webinars, and then we'll go into question and answer. In the future, we're going to talk about dual zipSTOP braking. So let me go back briefly. Actually, I'll cover that here as we go into Q&A, and I've got a chart to show that. But dual zipSTOP braking is really a super way to deal with, hey, having a full redundant system. So should you ever have a line cut or break on the primary brake, you have a second one in your system. Granted, it's costly to put on 2 brakes, but it gives you that margin of safety. It also limits arrival distance, so we can show you a way with 2 devices, and we will in that webinar, as to how to shorten your overall braking distance for all riders and tighten it up even at super high speed. So we're talking about over even up above 65 miles per hour, 100 kph. It's possible to bring people in at a relatively small platform in the 20 to 25 foot total platform range, or 6 meters platform when you're arriving at 100 kph. It's somewhat challenging, but we'll discuss that. 3-to-1 systems, part of those high speeds and other systems is an externally rigged 3-to-1. Currently, 3-to-1 systems are looked down upon a little bit just because you struggle to reset them. They're not automatically resetting. I'm going to show you how to reset a 3-to-1 system and rig it externally. Zipline rider and trolley interface is impact braking. So probably the probably the most important part of impact braking is how the trolley and the rider trolley impact and deal with the impact forces when you're impacting our brake or any brake puck for that matter on any braking system. Tandem systems, an emergency arrest device. So kind of piggybacking on that last bit, we'll be talking about how we go from tying multiple systems together to eliminate and mitigate huge braking distances so we can get short braking distances, tighter operation, and everybody's favorite word, better throughput, which means more money. We're going to go into EAD systems in one of these upcoming webinars. We'll talk a lot about the EAD systems available out there on the market. Retracted brake trolley or operation and training. What this is how you would set your operators up for success and train them if you wanted to pull the brake trolley in for varying wind and operational conditions. The reason you do this is, let's say you have a lightweight rider on a headwind in the group, and then his dad happens to weigh 250 pounds, and he's really good at aerodynamic positioning. So dad likes to come in and really use up the brake distance, and the kid likes to play around and barely make it into the terminal. So the way to deal with this is a tagline on the back of the trolley and a very specific methodology as to how you would change those braking distances and deal with the brake operation. It does come with some changed risk profiles for your zipline park, but it's a valuable tool in being able to dial in braking on the fly if you're willing to train your operators in it. And then we'll talk about some fun stuff like short distance steep angle ziplining. Steep angle being as much as 45-50 degrees vertical, which is kind of more of a jump ride, but we can show you how to use a trolley and our devices in reverse basically to descend against them on your fast angle zip line. This is great ways to get off your final towers if they're elevated. Just offer extra options for ropes courses and such. And also on the horizon, so we'll talk about some custom ways and rig our other devices. So not just this webinar series, but some other additional webinars in terms of talking about the quick jump and the true blue, and new throw rides and accessories for ropes courses, zip lines, and venue-driven rides. So you'll see a lot of head rush development is going into new products. We have a new reduction line. I apologize, the photo did not make it in here in time, but this is going to be one of your favorite tools to deal with. If you're dealing with sagging out there and you're installing the IR, we develop a reduction line for you that's 6 millimeters and meets all the strength and stretch requirements that we'd love to see. 18 kN yield, you're not going to get anywhere close to that with any other 6 millimeter line. It works because Dyneema core and a polynylon jacket has less than 3% stretch to yield, so it's not going to be super dynamic, which is what we want. We want it to engage the brake positively and repeatably. Lightweight and super durable. So again, it has a polynylon jacket, so it's pretty darn abrasion resistant. The Dyneema core is super hydrophobic, meaning it does not want to absorb water, so the thing's not going to really suffer in heavy rain or heavy moisture climates, which adds to sagging and bad performance. And you'll have this available in July. I know some of it's already gone out the door in beta testing, but the actual production stuff will be available here in July. Again, the redirection sheave. Let's see if I can pull that up really quickly. What we had to do, and if you understand redirection systems, the existing redirection pulleys out there, your Petzls, and I don't want to throw Petzl underneath the bus. It's any number of pulleys out there on the market, and please God don't use the cheapo ones you get at Home Depot or Lowe's, but something in the rated climbing territory. They aren't designed for these smaller lines. So these smaller lines have a tendency to, if the line's moving, and it's inevitable it will, it can jump to the side of the pulley, and then you end up with your most dangerous situation, which is grabbing the reduction line and either shearing it or jamming it, which of course creates two completely different but equally bad problems for your rider. If it shears it, they're going to come in almost without braking, and then if they jam, of course they're going to come in artificially abrupt, and they're going to impact the line, and they're going to be upset with you from that standpoint. So we'll show you this is, see if I can share this really quick. So this is the new redirection pulley, and I apologize that we don't have the real version photographed here, but this is what you're going to be looking at. It's relatively simple assembly. It scissors around the line like you're used to with any kind of Petzl or typical climbing rope accessory. It uses a very high-speed bearing, a high-speed aluminum sheave, and aluminum housing. The important part of this assembly is the when it's collapsed, you can see from the side here, from the front profile. Oh, sorry. No longer do you have a way for this line to jam. You have smooth entry points and exit points for the line at all times. This will deal with up to 7 millimeters. It also handles the 20 kilonewtons braking strength you're used to with standard redirection pulleys. So this is a huge issue. It's not really a patentable thing. This is something that's been out for 50 years, but for some reason was lacking in our industry for dealing with smaller diameter lines. So we went ahead and made you a pulley to deal with your 2-to-1 rigging, external redirection points, etc. That'll work quite well. I don't have a price point yet for you, but it's coming. Go back to my PowerPoint. Get a lot more new toys on the horizon. Unfortunately, that's about all I've got for today that I'm allowed to show and tell. But again, the webinar series is going to continue, so there's going to be a lot more stuff in the future that you're going to see. We have 20 new products in development right now, and within 12 new product lines. So some of them are complete departures from our existing devices and what we do. Others are evolutions of the devices and kind of new methodologies and new tweaks on the devices for greater performance envelopes. certainly you're welcome to ask any of those types of questions, and I'll try and be as forthcoming as possible. Most of you qualified to get in here, and we invited you because you've got some extended knowledge in how these devices work, and you've been out cheerleading for us, and we really want to make your lives a little bit better. So at this point, I'm going to shut up until we get some questions, and then we'll go ahead and deal with those questions. So we have a question about steel cable anchored to a tree. In what way were we looking at the steel cable mounted to the tree? Is that for redirection, or is that to hold the pivot mount, or?
Pivot mount?
Yeah. So yes, you can put the pivot mount on a steel cable. Again, the loading is 4,000 pounds, and you certainly could tie to a tree or extended platform in order to put the IR. The one thing that's going to come up, though, is this point must always be with the current pivot mount directly above. So this must be direct above the line. So if you got lucky and your tree were, let's say our tree is out here. This is why I'm an engineer, not an artist. And we had a line that passed exactly over the point that we wanted right here to allow for our braking distance of 20 meters if you're traveling 60 kph, right? Of course, if you're traveling less than that, you got to go to the charts, and then this number goes down. But in theory, if this were all happened and this cable were large enough, probably it's going to be a 14 mil or better. Don't hold me to that. Your engineer is going to be responsible for telling you whether that cable is going to be big enough to support that load. But then you certainly could. The joint is going to become a problem. So you're going to have this odd junction on a diagonal line where you need to change the orientation of the device so the device and the line have intersecting angles. It's possible. The key point is that the mount, if we go back to the mount picture, it's only designed to rotate and it's constrained. So this is a 3/4. This is a 3/4 quick link, and it's not designed to allow it to rotate off axis. So your challenge then would be getting this quick link or similar junction on that diagonal line if it wasn't running directly over. Hopefully that answers that question. The 4,000 pound force is applied directly down from the point. It also changes over time, but again, safety factor. So really what's happening is if I have my device and it's hanging down and I have two forces applied here, so we're going to apply, at some point in this arc, we're going to apply the maximum force, which is going to create a 4,000, well, it's not going to create a 4,000 pound load, it's going to create an 800 pound load. So if you've read our white paper, or you'd like to have access to it, this will give you this loading profile. And loading profile is going to take place as the angle changes. It's also, because brake force over time here is going to go up like this for your heaviest riders, which is going to represent this. Your actual peak force is going to take place closer to this 38-degree angle right here. So that's where your peak force is going to handle. Again, this is your direct no safety factor. Okay, so this is no safety factor force for 330 pounds. 330 pounds at 60 kph or 37 to 40 miles per hour. Now, if you go over these, if you decide to go 400 pounds, we're not going to say no, but please send us and we'll give you these load calcs back. If you decide to hit 70 kph, 45 miles an hour, this is an overload. And this one we're sensitive to. We don't like to see this. Most of the time we're going to point you to a 3-to-1.
We have a question about a mounting bracket in development for True Blue, and if that's going to be something we'll spend time on.
Yeah, so let's pull, we can actually pull that up for you. So we do have a davit for the True Blue. Actually, I want to see if I can still get this. This is going to describe it the best. We're also developing a davit and platform arrangement for the quick jump. It's a combination modular system. You'll see it makes mounting the True Blue on a pole or flat surface, gives you that perfect standoff. There we go. So we're uploading it right now. Also gives you the platform arrangement for the True Blue. So what you're looking at here is, this is the True Blue davit here. This is the quick jump. This is all modular, so this plate, you can't see it super close, but these will be ready here in July and August. All of these are the same pieces. You'll be able to climb up the pole with the True Blue type of davit. Doesn't have to be extended like this. What's shown is an option for extending it. It doesn't have to go out that far, but you can use the basic davit piece, the short bit right here. Will mount a True Blue from any location, really. So the second question is a lot of emphasis on stopping high-speed riders in a shorter rest zone. We have the opposite problem. We want our high-speed riders to cover more distance in cable when braking. What can we do? So that's an interesting issue. Well, high-speed riders should cover more distance in cable when braking. So what you're looking for, I suppose, is the 3-to-1. The 3-to-1 is going to allow you longer braking distance. The question becomes, how much do you want to deal with extra braking distance of the lighter people? So if we use a 3-to-1, and we'll ignore this for now, and pretend that we have our zipSTOP here, and we're arriving at high speed. It doesn't matter. We'll just say 60 kph right now. Oh, I'm going to reshare that. Apparently that didn't come through. There we go. So 3-to-1, 3-to-1 rigging. If you're not familiar, you're going to use an anchor point, zipSTOP, anchor point, pulley. System's going to go up, around, and then back. Just drew that wrong. Apologize. So in this 3-to-1 setup, well, of course, we talk about we're going to have a different webinar. The problem with this force is now the force of the retraction is divided by 3. So we're giving up a lot as far as reset goes, but your braking distance goes up quite a bit. So if you want to arrive over a longer distance and you want your riders, as your riders traveling down the line here, and they impact the brake. The implications, of course, are relatively obvious. Instead of doing this, here's the angle they'd be hitting with the standard 2-to-1 at high speeds. Instead, with a 3-to-1, they're going to be here. That's great for rider comfort, but of course it does increase the total distance. So if this is your max distance on a 2-to-1, this becomes your max distance, actually more so than that. This becomes your max distance on a 3-to-1. We are not authorizing, you can never do a 2-to-1 on an IR. There's some challenges with that. It has a place in the world, but that place is only specifically designed with a second IR behind it, an operational method, and then your braking distance is actually going to go out to here. This is an IR to IR. This is a 2-to-1 IR to an IR. Unfortunately, this only works this way, so you're not going to see it in the manual anywhere, but this is a way for you to get your braking distance longer. Of course, downside is your lighter weight kid, your now window of braking distance is going to be here to here, 330 pounds, and this could be 95 feet, and then your lighter rider could be 35 feet, and this would be 55 pounds. That's a huge window, right? This is a huge window for you to have to deal with a platform. But if you've got the window, you've got maybe it's a ground level installation. A platform like this certainly isn't too big a deal, and you do get maximum rider comfort. I can't emphasize enough, whenever you want to rig a 3-to-1, I'm going to erase here so I can continue drawing on this template later. Whenever you rig a 3-to-1, the key is reset, and you should check in for our webinar later, because resetting this system is a rigging challenge, to say the least, because you've got so many points, and in addition to those points, got another pulley here. In addition to these points, pulling all of this back, I apologize, my freehand needs work, but pulling this point back becomes a challenge. Like we stated in there, 3-to-1 does not reset automatically. Okay, next question. Hopefully that answers. Again, feel free to contact me if you have any more specifics or site installation specifics you'd like me to cover for your site. We are expanding our engineering department to help you guys deal with installations as far as guidelines for how your brake system should be covered in your specific site. That's it?
That seems to be all the questions coming in today, so if you've got any more, we're here for about 10 seconds, and then we're going to shut it down, I guess.
Yeah, thank you for letting me drone on. I know this will get better as I get more practice at it, but hopefully we helped you and we got a little bit of interest. Again, the important part is we get a lot of really cool advanced stuff that we're going to slowly release here in the next few months and give you guys via webinar and other resources to really help you build, help you design, help you improve throughput for your clients or your individual parks, really improve performance and safety across the board. Lots of new products too, so I didn't get to release a whole lot today, but that will be coming up soon.
All right, great. Well, thank you everybody for attending, and we'll see you at the next one.
Thank you.